The numbers used to balance a chemical equation are called coefficients. The reason we must balance chemical equations is because of the law of conservation of mass. Balance the following equation. Iron 3 chloride plus sodium hydroxide goes to iron 3 hydroxide and sodium chloride. So first thing that I'm going to do is I'm going to identify all of the elements that are within the equation. So I have iron, I have chlorine, I have sodium, and hydroxide makes it through intact, which means that I can count it as a single thing. On the left-hand side, I have 1 iron. On the right-hand side, I also have 1 iron. Chlorine on the left-hand side, I have 3. On the right-hand side, I have 1. Sodium on the left-hand side, I have 1. On the right-hand side, I have 1. Hydroxide on the left-hand side, I don't have any parentheses around it, which means that I have just one of them. On the right-hand side, though, I do have parentheses, and the outside subscript is going to be my multiplier, which means that I have a grand total of 3 hydroxides present. Utilizing Minho, I'm going to balance my metals first. That would be iron and sodium. Both of them are currently balanced, so that means that I can leave them alone. Next up is ions. That would be my hydroxide. So I have 1 on the left, I have 3 on the right. So I have 1, I want 3. I need to multiply by 3, so I'm going to go ahead and put a coefficient of 3 in front of the compound that contains hydroxide on the left-hand side. And then I'm going to recount. That not only changes my hydroxide number, but it also changes my sodium number. Now I'm going to go back to Minho, and I'm going to see that I now have a metal that is unbalanced. I have 1 sodium on the right-hand side, but 3 on the left, so I need to turn this 1 into a 3. So I need to go ahead and multiply it by 3 using a coefficient of 3, and recount. That not only changes my sodium, but it also changes my chlorine, and at that point, that balances the remaining atoms, which means that this is my final balanced equation. Any coefficients that are invisible are just ones. What type of reaction was the previous example? So my previous example here, I have iron 3 chloride and sodium hydroxide going to iron 3 hydroxide and sodium chloride. This is a compound plus a compound going to a compound plus a compound. Since I have plus signs on both sides of the arrow, it cannot be decomposition or synthesis. Since I have a compound on both the left and the right-hand side, it cannot be combustion or single replacement. The only option that I have left is going to be that of double replacement. Balance the following equation. Sodium plus water goes to sodium hydroxide and hydrogen. First thing I'm going to do is I'm going to go ahead and identify all of the elements that are present. I have sodium, I have hydrogen, and I have oxygen. I do see a polyatomic here of hydroxide. However, it's not super evident here, so I'm going to go ahead and leave the elements as separate rather than counting the hydroxide as a single thing. On the left-hand side, I have 1 sodium. On the right-hand side, I also have 1 sodium. On the left-hand side, I have 2 hydrogens. On the right-hand side, I have 1 plus 2, so I have 3 hydrogens. Oxygen on the left-hand side, I have 1, and on the right-hand side, I have 1. I'm going to follow Minho to go ahead and balance my equation. That says metals first. My metal sodium is balanced. Then ions. I didn't choose to use hydroxide, so I don't have any ions. Nonmetals other than hydrogen and oxygen, I don't have any. And then hydrogen is next. So I have 2 and 3. 2 does not multiply into 3. I need to force this to be an even number because I cannot multiply an even number by anything to get an odd number. So my easiest path forward is to force this odd into an even. So that means I need a grand total of 6. That is my lowest even multiplier for the 3. I don't know where I'm going to get that from first, though, so I'm going to go ahead and deal with the left-hand side. Since I know that I'm going to need a grand total of 6, I currently have 2, so that means I need to multiply it by 3. And then I'm going to see how that affects everything. So I have now 6 hydrogens on the left-hand side, and now I have 3 oxygens on the right-hand side. I am going to have to try to get this up to be equal as much as possible. So I have 1, I want 3, so I'm going to go ahead and multiply that by 3. That fixes my oxygen. It messes up my sodium. And it changes my hydrogen count. This goes from 1 to 3 and plus 2, so that gets me to 5. So that's not quite correct, not quite what I wanted. And then sodium, I can go ahead and fix that, put a 3 in front of there. So now everything is back to being fixed except for hydrogen. So this obviously was not the correct path. This isn't what I wanted to do. I still need this to be an even number. So that means my multiplier cannot be an odd number here. So I need this to add up. Instead of treating this as if it was all of my hydrogens were in the same place, which is what we were doing before, we are going to try to get it to add up to an even number where we have our just the odd one out subtracted. So I have 2 here, and I'm going to try to make it up to an even number. I have 1, 2 would get me there. So if I had instead multiplied my point of oddness, my odd hydrogen out here, by 2, that would have changed my hydrogen count to 4 here. It would have changed my oxygen count to 2 and my sodium count to 2. Now from here, I have 2, I want 4. If I multiplied that by 2, that would correct my hydrogen and oxygen at the same time, and then also corrected my sodium at the same time. Now, if you didn't find that point of oddness first and identified that this was my problem hydrogen, since it was separate, you would have eventually gotten there. But this is the fastest way to identify the point of odd and fix that first. What type of reaction was the previous problem? So the previous problem, I have a plus sign on both the left-hand side and on the right-hand side. So that means it cannot be decomp and it cannot be synthesis. I have a single element plus a compound going to an element, or a compound and an element. That most closely matches single replacement. And so that is going to be the type of reaction that it is. Balance the following equation. Silver oxide goes to oxygen and silver. So I'm going to identify all of the elements that are present, that it would be silver and oxygen. On the left-hand side, I have 2 silvers. On the right-hand side, I have 1. Oxygen on the left-hand side, I have 1. On the right-hand side, I have 2. Minho says metals first. So I'm going to do my metals first. Metal is going to be my silver. I have 1, I want 2, so I'm going to go ahead and multiply that by 2. That fixes my silver. And then I can move on to the oxygen, which is the last step of Minho. I have 1, I want 2, so I'm going to go ahead and multiply this by 2. When I do that, though, it messes up my silver. I do need to recount here. So 2 times 2 is now 4. So what was a correct balancing of silver is now incorrect. And so I'm going to go back in and I'm going to erase my first guess at a coefficient that was 2, and instead I'm going to go ahead and put a 4. And that gets me up to having 4 silvers on the left-hand side and on the right-hand side. Balance the following equation. Sulfur plus oxygen goes to sulfur trioxide. So first up, I'm going to go ahead and identify that I have sulfur and I have oxygen present. On the left-hand side, I have 8 sulfurs. On the right-hand side, I have 1. Oxygen on the left-hand side, I have 2. On the right-hand side, I have 3. According to Minho, I would do metals first. I don't have any metals. Then I would do ions. I don't have any. Then I'm going to do nonmetals other than hydrogen and oxygen. That would be sulfur. So sulfur is up first. So I have 1, but I want 8. So I'm going to go ahead and I'm going to multiply by 8. And then I'm going to have to recount because this 8 not only affects the sulfur, but it also affects oxygen. So 8 times 3 is going to get me to 24. So now I have 2, but I want 24. So my multiplier is going to be 12. And that would get me up to a balanced form for oxygen. What type of reaction was the previous problem? So I have a plus on the left-hand side, no plus on the right-hand side. The only type of reaction that has no plus on the right-hand side would be that of synthesis. So that is going to be my type of reaction. Balance the following equation. We have carbon dioxide and water coming together to form glucose and oxygen. This is photosynthesis. Okay, I'm going to go ahead and identify all of the elements that are present within this reaction. That is going to be carbon, hydrogen, and oxygen. As a general note, anytime that you see CHO, you should be concerned. This type of problem should take a little bit longer, so just kind of buckle up and be ready to try lots of things and try not to let yourself get too frustrated. So carbon on the left-hand side, I have 1. Carbon on the right, I have 6. Hydrogen on the left-hand side, I have 2. On the right-hand side, I have 12. Oxygen on the left, it appears in multiple places. So I have 2 here plus 1, so that gets me to 3. And then on the right-hand side, it also appears in multiple places. So I have 6 here and 2 here. So that's going to be a grand total of 8. According to Minho, I would do metals first. I don't have any metals. Then ions, I don't have any ions. Then nonmetals other than hydrogen or oxygen, so that's just going to be carbon. So I have 1, I want 6, so I'm going to go ahead and put a coefficient multiplier of 6 in front of carbon dioxide, and then I'm going to recount. So this not only affects my carbon, but it also affects my oxygen. 6 times 2 is 12, plus the 1 oxygen from water is going to be 13. Then continuing on with Minho, it is hydrogen next. I have 2, I want 12, so I'm going to go ahead and I'm going to multiply by 6. That would get me up to 12. But it's not only going to affect my hydrogen, it's also going to affect my oxygen count. So I had 12 from here and now 6 from here. So 12 plus 6 is going to get me to 18. Oops, sorry, not hydrogens, 18 oxygens. And then I'm going to try to figure out how to get the oxygen count up to get me to 18. Now, we just did a lot of work to balance our carbon and hydrogen, so I'm going to do my absolute best to not mess with the compound that contains carbon and hydrogen, because then I would have to rebalance those. So I don't want to do that. So instead, I'm going to see if I can get to 18, leaving the 6 alone and only messing with the 2. So if I need to get to 18, but I already have 6 accounted for that I'm going to try to leave alone, that means I need to get this oxygen up to 12. So 2 times 6 is 12, and 12 plus 6 is going to get me to 18, which meant that I was able to successfully balance without having to rebalance my carbon or my hydrogen. Balance the following chemical equation. Hydrochloric acid and calcium carbonate react to form calcium chloride, water, and carbon dioxide. So first up, I'm going to identify all of the pieces here. So I have hydrogen, I have chlorine, I have calcium, I have carbon, and I have oxygen. Now, calcium carbonate does include the polyatomic ion carbonate, CO3. However, carbonate does not make it through intact, so I cannot count it as a single thing, and I am going to have to count carbons and oxygens separately. Hydrogen on the left-hand side, I have 1. Hydrogen on the right, I have 2. Chlorine on the left, I have 1. On the right, I have 2. Calcium on the left, I have 1. Calcium on the right, I have 1. Carbon on the left, I have 1. Carbon on the right, I have 1. Oxygen on the left, I have 3. And on the right, I have 2 here, 1 here, so that is also 3. So that means that the only things that are messed up in the entirety of this thing is going to be hydrogen and chlorine. I'm going to look at Minho to tell me who I need to deal with first. It would say a metal. My metal, calcium, is fine. Then ions, I didn't have any. Non-metal other than hydrogen or oxygen, so that is going to be chlorine. So I'm going to find the chlorine compound, and I'm going to see if I can turn that 1 into a 2 by putting a coefficient of 2 in front of it. When I do that, it not only fixes my chlorine, but lucky me, it also fixes my hydrogen. And so that means that this is a balanced compound now with just that one change. Balance the following equation. Nitric acid reacts with sodium bicarbonate to form sodium nitrate, water, and carbon dioxide. So first I'm going to go through and I'm going to identify all the elements present. So I have hydrogen. I can see nitrate, and nitrate does come through intact. So I can leave nitrate alone and just count it as a single thing. Then I have sodium. I have hydrogen again, but I already have it accounted for. And then I see bicarbonate, or HCO3, but that does not make it through intact. So I do have to break up carbon and oxygen here. So hydrogen is in 2 places on the left-hand side. I have 2 of them. On the right-hand side, it's just in 1 place, but I do have 2 of them. Nitrate, there are no parentheses around it, which means that I only have 1 nitrate on the left-hand side. No parentheses around nitrate on the right-hand side either, which means I only have 1 of them as well. So that also means that I just have 1 nitrate on the right side. Sodium on the left-hand side, I have 1. Sodium on the right-hand side, I also have 1. Carbon on the left-hand side, I have 1. Carbon on the right-hand side, I also just have 1. Oxygen on the left-hand side, other than the oxygen within nitrate. Be careful not to count the oxygen in nitrate. That was already accounted for within the nitrate count. So oxygen outside of nitrate, I have 3. And oxygen outside of nitrate on the right-hand side, I also have 3, which means that this equation is already balanced before we've done anything. So the coefficients are going to remain 1 across the board.